So the lesson which we are going to take today, that is the senses. How many senses we are having, right? So today we are going to study senses. How many senses we are having? Who can tell me? Yes? Five. Who can name it? Mm-hmm. Yes. Mm-hmm. Yes. That's good, right? So five senses we have: sense of smell, sense of touch, sense of vision, sense of hearing, and taste. Right? So these are the five senses which we are having, which we are going to discuss. Or the sense, the initial receptors present to the sense, right? The initial receptor from which we get stimulus from inside the body or from outside the body. We live in a world of sensation. Our senses are our link to the experiencing the outside the world, and we often take them for granted. So, like for example, how we are sensing things, like for example, sense of touch if you took, right, or sense of any type of sense if you took. So, what we are actually doing, we are actually feeling it, right? We are receiving the stimulus, right? Like for example, if it is use, if it is ink, it's food, right? If it is noise, right? If it is like test, right? If it is light, anything which we will feel that, right? It will come in what? It will come in sense. How would you describe the sensation of seeing red as opposed to blue or greens? To someone who was blind, or how would you will describe the test of an apple to someone who had never tested one before? Right? So all these things will come in what? All these things we will know with the help of what? With the help of the sense organ, or with the help of different senses. The inputs we get from our senses are almost impossible to describe, and yet we use them every moment of the day. Right? So different senses which we are going to study. The first one which we are going to study, that is what? Touch and related senses. How does the body sense touch, temperature, and pain? Right. So how temperature and pain will be senses by the body? The way the body is going to sense. Cheer. Tell. So who can tell me how we feel the pain or temperature? Last students. How we feel the pain? How we feel the pain? With the help of what? With the help of nervous system. In nervous system we have what? Which nervous system? Which type of nervous system? And we feel with the help of the skin. With the help of the skin. So skin will receive the signal, our skin will receive the message of the pain, and it will be given to it will be received by the part or the receptor, like skin. It will be given to it will be taken by the peripheral nervous system first, then it will be given to the central nervous system, and central nervous system is going to produce what? It's going to produce message, right? And that message will be, it will give response. Touch and related senses. How does the body sense touch, temperature, and pain? Right? In which way the body is going to sense touch, temperature, and pain. So different sensory receptor in the body respond to touch, temperature, and pain. So in the body we have different type of receptor in different part of the body. Different sensory receptors in the body respond to touch, temperature, and pain. Touch and related senses, because nearly all regions of the skin are sensitive to touch. Your skin can be considered your largest sense organ, right? The largest sense organ of the body should be skin, right? Skin will be the largest sense organ in the body, right? Different sensory receptor in the body responds to touch, temperature, and pain. So if you look to the body, right, there will be different sensory receptor, right? If you look throughout the body, it will respond in the case of what? It will respond in the case of touch, right? So with after touch, it should be either what? It should be either temperature. It will either respond for temperature. It will either respond for pain, right? Or it will either respond for what? Receptors. It will respond either for other sources like light, right? Like for vision, like for test, for different it can be there. All of these receptors are found in your skin, but some are also found on the other areas, right? Like only two type of receptors. If we talk about what? If we talk about the temperature, if we talk about the pain, right? These two type of receptors is present in what? It is present in skin. But if we talk about rest three type of receptors, right? Or rest of the receptors, other receptors. So it is present where in which part of the body? It is present in rest of the body, right? Like for example, if we talk about the chest, so chest is present where? Chest is present where? In mouth, right? Chest in mouth. What about sight, vision? Right? Eyes. What about ear? Ears, right? Which is another? Smell. It's in the nose, right? So in different part of the body, it will occur. The first point which we are going to take there is about related to touch. Then we will go to related to temperature, and then it will be related to pain. Human skin contains at least 7 types of sensory receptor, including several that respond to different level of pressure. How many types of receptors we are having? Roundabout, we have 7 types of different receptors present in the human skin. Right? In the human skin, we have 7 different types of receptors. Depends on what? Depends on the pressures. Right? If it is going in the skin, right? Like someone is going to snap you, right? One side of the receptor is going to receive it, right? If you are going to touch any surface with less pressure, one side of the receptor will receive there, right? If you touch any other surface which is too hot or too cool, right? So for this, it depends on the pressure, right? Stimulation of these receptors create a sensation of touch. If you look to the stimulation of these receptors, so it will create the sensation of touch. How a receptor is going to stimulate, right? Stimulation when any receptor receive message. So this is called stimulation, right? When any receptor receive signal, there is called stimulation. So stimulation of these receptors create sensation of touch. Like for example, you touch a hot surface, you touch a cool surface, right? Or you touch like you can say spiny surface. So that's what there is the receptor which is present in your body, it will receive the stimulation or you can say sensation. Not all parts of the body are equally sensitive to touch. For example, the skin on your finger has much higher density of touch receptor than the skin on your back. So now if you look to the division of what? The sensation, the sense of the body, the skin. So if you take some part of the body, it will be highly sensitive, some part of the body it will not be highly sensitive, right? Like for example, if you are going to touch something, right, to check it when it's cool, it is hot. So first of all, what we are doing, we are going to touch with the fingers, right? So fingers are highly sensitive, right? In case of touch, right? As compared to toes, as compared to the other part of the skin, like back or any other part of the skin. So the most highly sensitive part of the skin is what? It is fingers, right? The most sensitive part of the skin is what? The most sensitive part of the skin is what? Fingers. Good question. Okay. Next, related to temperature, right? So the thermoreceptor are a sensory cell that are response to the heat and cool. Now, as we said that in the skin we are having what? In the skin we are having 7 different type of receptors, right? So now, if you look to the name thermo means thermal. Thermal means what? Thermal means heat temperature, right? Thermoreceptors are sensory cells that respond to the heat and cool. So thermoreceptors are those receptors which is responsible for what? Which is responsible for the temperature. Thermoreceptor are the receptor which are responsible for what? Which is responsible for the temperature. Like if it is cool, if it is hot. Let's suppose now at the morning temperature was what? In the morning it was around 10, right? So how would you get with the help of our thermoreceptors? Right? Let's suppose now if you go outside, right? So the temperature will be 15, 16 or 20. How we will feel it? We will feel it with the help of the thermoreceptors. They are found throughout the skin and in the hypothalamus, the part of the brain that sense blood temperature. Internal and external stimulus we have, right? Internal and external stimulus we have, right? So the one that the thermoreceptor which is present on the skin, the thermoreceptor which is present on the skin, it is going to regulate or it is going to report to which part? It is going to report to the hypothalamus, which is present in the brain. And we know that hypothalamus is a part of the brain which is associated with what? Which is associated with a function related to the temperature, right? And we call it thermoregulatory center, right? Thermoregulatory center, TRC. Yes, thermoregulatory center, which is present in the brain, and to be specific, hypothalamus. We can say here is hypothalamus. And beside this hypothalamus, as it's the internal body part, so it is if it is the internal body part, so mean it's already associated with the blood, right? So hypothalamus can directly monitor or can directly sense the temperature of the blood, right? It can sense direct the temperature of that. Clear? Now next point we have that is pain. Pain receptors are found throughout the body. Throughout the body, right? If there is a receptor in the body, it will be pain receptor, right? Throughout the body. Some especially those in the skin respond to physical injuries like cutting or tearing. Right? Like for example, if you look, right, any place cuts like a tear, so we feel the pain, right? So that is what? That is due to how we are going to feel it. We are going to feel it on the basis of what? On the basis of that receptors which are pain receptors. Many tissues also have pain receptors that respond to chemical released during the injection or inflammation. So if you look to the many receptors which are inside the body, right? Many tissues also have pain receptors that respond to chemical released during the infection or inflammation. Like let's suppose we become sick or ill, right? We don't see it on our skin, we don't, but it's inside the body. So the infection is other inside the body. So when it is inside the body, it will still be detected. It will still be detected and it will still be received by the receptors. The brain, interestingly, does not have pain receptors. For this reason, patients are often kept conscious during brain surgery, enabling them to tell surgeons what sensations are produced when parts of the brain are stimulated, right? So if you look to the brain, so here in the brain we do not have any pain receptors. For this reason, patients are often kept conscious during the brain surgery. Practically, if you are going to do brain surgery, right? If you are going to do brain surgery, from this point, it's supposed that if you are going to do brain surgery, we don't need to give anesthesia, right? Anesthetic drug to keep the person sedated. But some people are asking that How? Still we are giving. Still, what we are doing? Still we are giving medicine or anesthesia medicine to the patient. Why? The reason to this point is that we say that in the brain we don't have pain receptor, right? In the brain we don't have pain receptor. But if you are going to the brain, right? Brain is where? Let's suppose brain is present here, right? So in the brain we say that here we don't have pain receptor. Pain receptor is not here, right? But this part, if you look, which is skull and which is skin, skin. So skin over the skull is contained, it has pain receptor. So if you are going to cut, if you are going to cut the skull, if you are going to cut the skin over the skull, so it has a pain receptor. So in that condition, if you are going to do a hard brain surgery, so then we are giving anesthesia drugs. Why? Because we have to cut first the skin, then we have to cut the skull, and then we have to reach what? Then we have to reach to the brain. So that is the reason that doctors are giving, surgeons are giving anesthetic drug to the brain when they are doing brain surgery. Okay. It's clear? Okay, now we are coming one by one to the senses, right? First we have smell and taste, right? How are the senses of the smell and taste similar, right? Somehow we have similarity in both of them, right? Sense of smell, which is present, they are present, where they are present? Sense of smell, where? And sense of taste, mouth or on the tongue, right? So they are present there. How are these things? They are similar. Sensation of smell and taste are both the result of impulses sent to the brain by the chemoreceptor, right? If you look chemoreceptor, who can tell what is chemoreceptor? Yusuf. Chemoreceptor. Chemoreceptor, that receptor which is going to stimulate with the help of the chemicals. Chemoreceptor is that receptor which is going to stimulate with the help of the chemicals. So if you look to the sense of smell and sense of taste, right? So they have similarity. Why they have similarity? Because they are going to stimulate by those methods which are produced by the chemical. By chemicals mean the food we are eating. It is chemicals, right? Carbohydrate, right? Glucose, C6H12O6, right? Like we will take carbohydrate, right? Glucose, let's suppose. So glucose we have. So 6, right? So this is what these we are all we are having chemical, right? So this chemical is going to stimulate what chemoreceptor. If we are going to breathe, right? So within the breathing, the sense of smell, right? We are taking it. So it's also what? It is also chemical. So it will stimulate. It is going to stimulate the chemoreceptor. Your sense of taste and smell involve the ability to detect chemicals. That chemicals which are present in your food, right? Which chemicals which are present in the food you are eating? Chemical sensing cells known as chemoreceptors. The nose and the mouth are responsible for both of these senses, right? So both mouth and nose contain what? Mouth and nose contain chemoreceptors, right? Chemoreceptor will be present here. Chemoreceptor will be present in mouth and nose. Your sense of smell is capable of producing thousands of different sensations. Much of what we commonly call the taste of foods and drink is actually smell, right? So sometimes smell and taste, right? They are producing thousands of different sensations, right? But both of them they will be covered by what? Both of them they will be covered by either mouth or either by the okay. Sensory cells in the taste bud respond to salty bites, sweet and sour foods. Recently, a fifth kind of taste sensation was identified, now called umami, from the Japanese word of savory. Right? If you look here, if you look to the tongue, right? So in the tongue we have four regions, right? On the tongue we have how many regions? On the tongue we have only four regions, right? And which are going to detect different tests, right? Their four regions as test buds, and they are what are they? First, they are going to detect one test bud are going to detect salty, another is going to detect bitter, sweet and sour, right? Now, recently, the fifth one is being identified by some of the scientists, which is called, yeah, which means sour flavor, right? Sour flavor. So these are now the five taste buds which is present on the tongue. One receptors are strongly stimulated by the monosodium glutamate, right? MSG. Monosodium glutamate. It is a chemical substance often added to Asian food to enhance their flavor, right? It is what? It is monosodium glutamate. It's a chemical, you know. They are also stimulated by meat and cheese, which typically contain the amino acid glutamate, right? This soury bird, right? This soury bird, which is related to what? Which is related to the MSG, right? Monosodium glutamate. So it is also being stimulated by what? It's also being stimulated by the meat or cheese. Because if you look to meat and if you look to cheese, right? So both of them contain what? Both of them contain amino acid. Which type of amino acid? Glutamate, right? Which contain amino acid glutamate. And we are saying that monosodium glutamate, MSG, it is a substance which is going to stimulate that receptor. Right? Now, this is clear. If you have any doubts till here, so you can ask me. If you have any question here, you can ask me. And smell and test. And smell and test, if you have any doubt, you can ask me. Sir, you're sleeping. Hearing and balance. The next one we are hearing, it is what? It is hearing and balance. How do the ear and the brain process sound and maintain balance? Right? So this will occur by what? This will occur by how do the ear and the brain process sound and maintain a balance? So mechanoreceptor found in a part of the ears transmit impulses to the brain, right? Mechanoreceptors is responsible for listening, right? For sound, for waves. Mechanoreceptors, which is present in which part? Mechanoreceptor found in a part of the ear transmit impulses to the brain. Where it will be present? Mechanoreceptor. So mechanoreceptor will be present in the brain, in the ear, right? And which will transmit messages or impulses to the brain. The brain translates the impulses into sound information about the balance. So then the brain are going to interpret, are going to translate these messages, these impulses into sound and information about the balance. The hearing has two sensory functions. Hearing and detecting positional change associated with the moment. So if you look to the human ear, it has two main functions. It has two main sensory functions, right? First, hearing and detecting positional changes associated with the movement. First, hearing and then detecting the position, which is associated with the movement. Like for example, if someone is talking right near to you, you can listen to it and you can even feel the distance, right? But if the same person are going to talk with the same sound, right? Same volume and it's talking from outside. So then you can feel that now this person has moved from here. Right? So two things we are going to feel. One, a hearing and other we can detect the movement. Mechanoreceptor found in a part of the ear transmit impulses to the brain. It is present where? It is present in the part of the ear and it's going to transmit the messages and impulses to the brain. The brain translates the impulses into sound and information about the balance. How the process of hearing is going to occur. Sound is a result of vibration moving through the air around us. The way we are talking, right? So it is actually vibration, right? It's actually vibration, and that vibration is moving with the help of what? That vibration is moving with the help of the ear, and it reaches our ears, right? If you remember, you have studied waves, right? Waves are in which time? In physics, you are studying. No, no, in the form, right? Like in this form is coming. Right? It's coming in this form. If you look to the sound wave, it is coming in this form like I'm talking, right? So the way I'm talking, it will be sound wave, it will come to your ear in this way. The ears are the sensory organ that can distinguish both the pitch and the loudness of the sound, right? The pitch of the sound and loudness of the sound, right? If you look to the wave, right? So wave in this land where we have what? All the things you know because you're studying physics, right? Vibration, vibration enter the ear through the auditory canals and cause the tympanum or eardrum to vibrate, right? This part, right? This part is called what? This part is called eardrum, right? Or tympanum. So now the function of the eardrum is what? The function of the eardrum is to vibrate. When the sound falls on this part, right, this sound will go and it will strike on the eardrum. So when it strikes the eardrum, it will give vibration to the eardrum, right? So when it gives the eardrum, so when it gives vibration to the eardrum will produce vibration and it will give it to what? The nerves which is present in the ear, we call it nerves. Hearing nerves, sound nerves. This bone is called ossicle, right? So it will be produced by the ossicles, and ossicle will generate a nerve, and ossicle will generate a message, and that message will go to what? That message will go to the brain, into the nervous system. Three tiny bones, commonly called hammers, angle, and strut. These are the three bones which are present in the ear, right? Transmit these vibrations to the membrane called the coil window, right? So when the sensation or the vibration come from outside and it strike the what? And it strike, suppose it strike. Let's suppose this is a wave or this is a sound which has come to the ear. So in the ear we have three the bone, right? The small bone which is present in the ear, they are divided into three type of bone, which is hammer, angle, and strut. Right? So these three bones transmit this signal, right? It transmits this signal to what? It transmits this signal to a membrane, which is called what? Which is called window. Vibration here create a pressure wave in the fluid filled cochlea of the inner ear, right? So when these vibration occur, these vibration will create what? These vibration will create pressure in which part of the ear? In the cochlea of the inner ear. The cochlea is lined with the teeny hair cells that are pushed back and forth by these pressure waves. So now, right, the cochlea, we also call this bone coccyx, right? Cochlea is linked with the tiny hair cells that are pushed back and forth by these pressure waves. The motion of these sensitive hair cells produce nerves and pulses that travel to the brain through the cochlear nerves. The brain processes these nerves and pulses as sounds. So when these sounds are produced, these sensations are produced, that sensation, right, it will be given. The motion of these sensitive hairs, they are going to produce nerves and pulses, right? That are going to travel to the brain through what? Through the cochlear nerves. Cochlear nerves, which is arise from the cochlear from the ocular part of the ear, like we can say from the three type of bones in the ear. And these, the brain are going to process these nerves and pulses, and they are going to produce the sound later on. Now the next point which we are having here, that is about balance, right? So ears contain structure that help the central nervous system maintain balance or equilibrium, right? So in the ears there is a structure which is going to help the central nervous system to maintain a balance or equilibrium in the body. Three tiny canals within the inner ears called semicircular canals. How many canals we are having? We are having three semicircular canals, which is called what? Which is called semicircular canals. The two tiny sacs located behind them monitor the position of the body, of your body, especially your head. The two tiny sacs located behind them monitor the position of your body, especially your head, in relation to the gravity. The semicircular canals and the sacs are filled with the fluid and linked with the hair cells. As the head changes position, the fluid in the canal also changes the position, causing the hair on the cells to bend. This bending sends impulses to the brain that enable it to determine body motion and position. So when you are going to change the position of the head, so it will determine the position, the balance of the body, right? So we will stop here. If you have any type of question, you can ask me.